Hello everyone. I am just going to do a quick recording on my presentation here. Just going to pop this open and we're going to zoom in here. So, what I have been researching is a distributed defense system against DDoS attacks. Um, in the papers that I've been reading, it's been a pretty big note, almost the main notion that in order to stop a distributed attack, we're going to need some kind of distributed defense. So first we're going to kind of go over how a DDoS attack happens here. You have your server and you have all of the routers that connect all of the computers all over the place to that server. And what happens is some of these computers are infected with a virus that causes them to essentially just slam the server with packets over and over and over and over again until the server can no longer keep up with requests. That part is simple enough. So what they've been doing, at least in the paper that I read, is they used a C4.5 decision tree algorithm. It's based off of an earlier algorithm that the same person wrote for this. What they do is they take their TCP packets and they run it through a network analyzer. I don't remember what the program is called, but they analyze all of these packets that come in, and the decision tree poses a series of questions, and each time there's an answer, it's a machine learning method that goes down the list and basically decides. So here we have a question, and if the question returned a no, then that would be the end of that. It would most likely be, in this example, legitimate traffic. But if the question answered yes, then it's possible, hey, this might be illegitimate traffic. It could just be an attack from a botnet. But if not, you can still cut the process. It's still legitimate traffic, or eventually you'd come to the conclusion that yes, that is not legitimate traffic. I did look up some of these algorithms on GitHub, which surprisingly you can find all of them. So here we have the symbiotic based bid-based framework. This is a algorithm that they use in genetic programming. They are using it in this case to essentially try and create a feature set for the analyzed data packets, and after that they can use machine learning to decide if it is legitimate traffic or if it's botnet traffic. All of them are on there. They're pretty cool, and a lot of them are very robust. I found them all in Python, excluding the botnet that I'm going to show you all. It seems as though Python is a desirable language for things of machine learning and things of that nature. So that's cool. The symbiotic-based algorithm is used to determine if the packet is legitimate or not. The problem that they experienced in the research is that each independent algorithm only worked so well for every single different type of botnet. There's several different types of botnets out there. One algorithm, this particular one, the symbiotic bid-based framework, it was good for identifying a certain one, but it couldn't identify other ones. We will go back and we will check out another one here. This is the C4.5 algorithm. It's actually pretty simple. It's very cool. If you download these off of GitHub and you run them, they actually run. No problem. It gives you some test arguments and spits out some test answers. So those are the two algorithms that are being used for the machine learning in this scenario. So the idea behind what they're doing here for this distributed defense, so we're just going to zoom in again and we're going to come on down here, is they set up a series of defense nodes alongside all of their upstream routers. So they set up these defense nodes in a way that every single defense node is going to cover every point of access to that network. So this server is completely covered by defense nodes. You would never be able to contact this server without going through one of these defense nodes. The idea behind it is if you have a distributed system, and as you can see, all of these defense nodes are connected to all of their closest neighbor routers. Every single one is connected so that they can all talk to each other very quickly and really easily. What happens is if it starts to detect any botnet traffic, say we're getting botnet traffic from over here, these highlighted computers here, I'm sorry, they're just C's. This is all hand-drawn, as you can see. All of these highlighted C's, say they were part of a botnet attack. Well, as you know, a botnet attack can come from any computer all over the world. So it might be this computer, and this computer, and this computer, and this computer. But the problem is with what happens here, what we see is the defense nodes actually tell each other, hey, I'm starting to experience some botnet traffic. So this node will tell this one, and then these nodes will tell this one. And the server is a lot more defended as opposed to if you had a single defense node, all of your server traffic would funnel into that one defense node. And the problem with that is the same problem that you would have with what happens when you get a server DDoSed. It just gets overwhelmed and it crashes, and that's pretty much the end of that. Just as an example, we're going to take a quick look at the botnet that has been used in one of the more largest DDoS in history. It is the Mirai botnet. It's used on Internet of Things devices. It's pretty cool. It's insanely robust, as you can see. There's all sorts of different files in here. There's mostly C files, and there are some Go files. I believe they use the Go files for communicating with databases. But it was also built semi-professionally, as you can see. Let's see here. We have a compiler piece right here so that you can just basically run this program and it's going to go through and do everything that you're going to need. It'll install everything you want. And we all can note here that it was written by a professional, but still an asshole, if a professional nonetheless. And you'll find comments pretty similar to stuff like this up here at the top all throughout. There's even a instruction section here, a how-to, so that you can start up your own botnet. Apparently you can contact the creator with some certain questions about the botnet. They will not be providing any kind of tutorials. However, the botnet is pretty much packaged, scripted, and ready to go as soon as you download it. Very cool. And of course, if you guys wanted to download any of these, you can just check them out on GitHub. There have been other defense systems that people have come up with in the past in order to try and stop a DDoS attack, but so far, not so good. Machine learning is being employed a little more often in the analysis of these botnets, just because the obvious answer when you have a ton of something and you can't figure out what it is very easily is to train up a machine learning system that can identify when you're experiencing that kind of thing.